Okay guys, welcome to the stream. It is Saturday morning, 6 a.m. First of all, let me to check my audio. Let me to turn off the fan. Now it's more peaceful, I think. Do you hear any extra noise? Maybe refrigerator, right? Maybe refrigerator. So I think it's fine. So from this, let's begin our live stream, live coding stream. Okay, guys. Yesterday I was out. Yesterday I didn't make the stream because I was in another city. But I have a news for you. I have a great news because we have we have hardware. Okay, we have a hardware. We got this hardware. Can you see it? It is Jetson Nano development kit. Okay. It's not development kit, it's just hardware, just a nano, okay? So we have this hardware, okay, guys? And then we have this hardware, this computer, okay? It is Jetson Heavier NX development kit. So this guy is strong. And it is much stronger than Raspberry and Arduino. So we have these two hardwares. Plus, I have this JetBot. See? This JetBot. So we can use this JetBot hardware also, guys. So that's our news from yesterday. And we have this hardware, okay? We need to write software, of course. We can write software, we can download software, we can, install Linux, and etc. So we, in last stream, we couldn't finish this logic. Keyboard input. Write a program in assembler which write keyboard input into memory. The keyboard input is memory mapped to address 6000. Write the first character typed at memory address 1000. The second typed at 1001, and so on. Note, a key will usually be held down for much longer than a clock cycle, but should only be registered as a single input until the key is released. So what I did, I cannot directly get the registered key. I can only directly go and talk to register A first. And then I can define a target. I can assign to the D's value of A and assign to the star A the value of A. Star A is a RAM. Is a memory. A is anything. It's a register. So this is address. This is address. So a key will usually be held down for much longer than a clock cycle, but should only be registered as a single input until the key is released. When it is pressed, we should register, and that registration should be just before key release. What kind of ideas comes to my mind? We need to use this kind of GNE, and other kind of these jump conditions, I say. So this is registration, okay? No, this is whole registration idea. But this registration should be done. So this registration should be done when it says a key will usually be held down for much longer than a clock cycle. So one clock cycle means this whole one process. No. Clock cycle. Clock cycle means one cycle. Clock cycle means A equal to 0x hectagon 6000. This is one cycle. Another 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 cycle. So we write down to the target the prop value from D to the target memory. And I use this G and E. Definitely this might be wrong, because when we run it, the current diagram doesn't comply with the specification. Press A, sticky shift A, right, for 10 clock cycles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So memory 1000 should be 0x41. It should be. Let me to delete this guy. Let's run more time. Reset. Tuk. Check solution. It says it's wrong. Hectagon 1000. Again, let's start again. Okay, d equal to a star, so d now should be 0.41. Yes. A equal to the target, it means a should be 1000. Yes. Now a star is equal to d, so d is this value. So I'm saying that memory address at a target, write a d to the target. So this guy should potentially write it, and this guy is just make assign new address to a, do new things to a. Maybe let's comment it out for now. See, it has another idea. It has another logic. It has another logic. See, it says you need to have a 10 lines of code. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where is from? Where? No. Star A equal to D. Star A is equal to D. Tick. Tick, 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 tick. 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 Yes, hexagon 1000. 1000. Okay. Tick. We're not using this internal, right? How to use this internal? What about this if we use these bitewise things? Okay, it's not quasi. Check selection. Press it A, press it A. Can you see it, right? Look. So it says A equal to 1000 star A equal to 41, B equal to 41, star A equal to B when keyboard is pressed but not yet released. When it is pressed, when it's pressed, the memory address at 6000 will change. Can I have star B? Star D? Do you have star D? Definitely this is wrong. It says it's wrong. Let's say it is the one. If I say D, it's fine. Just something like this. It's not fine. So we don't have that kind of thing. It's just D equal to 1. Why it's so tough? Tough. We are missing something, you know. It should not be like that. And now I can go and start A. I can do bitwise. What was this? What was this symbol do? What does it do? This symbol. It was OR. OR. let's say star a is equal to 0 and repeat this guy. What you want? Write the first character typed at memory address 1000, the second typed at 1001, and so on. The key will usually be held down for much longer than a clock cycle, but should only be registered as a single input until the key is released. How can I know when the key is released? So in order to know when the key is released, we can use, we can assign A to the ones to 6000 and then compare the D and A star A. Then we can check if it is released or not. I don't know. We need help. We need help here. So look, there's one guy in Reddit. He said he cannot. He is stuck in the same place as we are. So he cannot assign other values. So he's using a label loop. Let me to check the label. Keyword label follows by a name makes a name presents the address of following instruction. The address can be assigned to A before a jump, A equal to a loop. The keyboard label followed by a name makes the name represent the address of the following instruction. this address can be assigned to a before a jump. For example, a equal to the loop. So we said, oh, what happened? So we said this guy. So we said not this one. 1000. I see. I think I see what we can do. So guys, let me to say label equal to loop. Okay. Does it work like this? Like that? Okay, without equal sign. Following instruction. So it means when I call loop, it will execute the next instruction only, right? What does this line do then? Okay, this one assign to the A address and get the address value to the D register, and then assign A to the loop. The keyboard label followed by a name makes the name represent the address of the following instruction. Just wait, visit. T equal to, let me try this one. Just wait. When I say A equal to the loop, A is equal to what? A equal to this one address in here. Let's see. Sticky shift A. Tick. Okay, so 6000. T equal to A star. A star is 0041, so it will be that. A is equal to the loop. A will equal to this address in 1. 0001. Okay. And then we are changing A to the another address and writing A star A to the T. And then let's check solution. Fine. At least we have ideas that A will be equal to 0001. So we can increment like that. Makes sense? So it means, let's say A is equal to 1000. Oh, see. So now in this 3, A will equal to be 0.0014 1001. If I say like this, or can I do like that? Expected either a register A or D or a number found in let's see. Tick 1000 00001. It's 00001. We don't want that. We want when it goes up. Oh. It's just going downward. Okay, let's see another idea. A equal to the root. A equal to the root. Why he's saying 2 times A equal to the root, A equal to the root? Let's try. So he's saying that A equal to the root one more time. Let me do run. Tick 1000, yes. 1. But what does it D Q J E Q means? Oh, it set it back. This one set it back. See? So, if I remove this one, then it just goes forward. If I use this one, it makes it go back. See? Go back. Go back. Go back. Go back. Go back. Why back? I don't know. Because D here is 0. If I change it 6000, now it should pass. Why it's not working? Tick, 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 tick. It should go to next. Yes. A equal to the 1000. And now we write to the A, and now we are doing a loop. Let's check solution. Okay, fine, good. We did fix one bug, and now we are in second bug. I'm interested. D is here, it is 0041. Can you see me clearly, guys? See me clearly? I have to fix my posture. Okay. D, G, Q. But let's say if I say like this, it should jump to where? This should jump where? It should jump to here? It should jump to here? No, it jumps to here, right? Let's do it. Tick, 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 okay. Tick, 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 tick. Reset. Tick, 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 tick. Do I need this one? No. What happens to this guy? Okay, if we by accident we closed the window. It's fine. If I say no check solution, I want to do like this. Okay, let's do A. Okay. What? Wait. Why I should touch the D? Doesn't make sense. What if I do like this? A. What does it mean? Okay, it seems we need to add A equal to loop. And then we can compare, let's say just 0. And it will just jump. Jump. Okay. Now we should change the 0 to another value. Just think. We don't need to know any ideas. We don't need to know the solutions also. It's hot here. It's too hot here. It's too hot. So we have a label, and that label allows us to directly go to that address, to that line, and execute it one more time. It is like a for loop, while loop in Python. Okay, this makes sense. This is good idea, good implementation. This whole is good, very good, excellent. Because the idea is that only execute, go to the next line when you get a value other than 0 in D. When D has a value other than 0, shall we introduce a new loop, new target, new label? Like this. If I do like this to A, should it jump to here or here? Here. Let's see. 1, 2, 3, 4, 5. D. Okay, we assign A to the 5. To 5. Now should go here. Oh, good, good. So yeah, it's going to here. Our assumptions are correct. So then, star A is equal to D. A is equal to letters loop. Okay. Now we write to this address value. That's fine. But when we should write it? When we have address from the address 6000. Yes, we have address from 6000 and we write it to the address 1000. The next idea is that when we write it, we should write it before a key release. So we write it and then what should we do? Should we call and go here again? So idea is that maybe we should just call loop when we call loop, when we need to go jump, when we need to jump, we need to jump when keyboard value changes. How we can know that keyboard value changes? So first of all, we can assign to the A 6000 Then compare, like a equal to 6,000, and then star a minus t star a and minus d should have something in common, you know. Now, if I do like this, when there is no change, it should go return to the label. No. Now, when keyboard is released, only in that case return. Okay. A star minus t GEQ equal to 0. G and E. It says error. G and E. GEQ. Okay, look. Okay. What is this then? A star minus. It is equal to 0. When I press one time, it should just be pressing, and then it should write it to the memory. And what it should do, it should just wait. It should wait. Definitely. It should wait. What if I just ignore this stuff? A is equal to the loop means A equal to 0001, right? Can I say something like this? Oh, define value 0. What? No. It's a bit difficult because I'm using the Vim like browser. Insert star A minus T. We have a problem. Number. Give me a number. Here it should not be 0, you know. A is hook, right? Wait, what is the value of star A here? Oh, I'm tired, guys. I'm tired. I'm a bit tired. One sec. It is 0, 0, 0, 0. Not good idea at all. You know, I can say can I execute the whole idea only here? And this part is only responsible to writing it. Okay, it will go a big return. Okay, so here a equal to the 6000, and we should not write directly to the d, the star a. We should write star a to the d only when what? What are the conditions? The first condition is that d should not be 0. Condition 2, d should not be the same value as before. For example, d equal to 0041 should not allow to write 000041 again. So that's our idea, you know, the requirements. Okay, this one satisfies the first one. How can we satisfy the second one? Just believe, guys, believe, and we can fix it. D should not be the same value. I can say, you know, we can go to A and to what address then? And then if I get this one, if I say like this, so we have the address. So I add this one, and I hope this one will satisfy the second requirement. Second requirement is that D should not be the same value as before. For example, if before D is 0041, and now it is D is 0041, it should not be same. Otherwise we should not write it. But here idea is that our address is dynamic. It's not always 0 hex 1000. It's not always like that. It may change, you know. It may change. So it is another problem. Let's try. What? Stop. Tick. Tick. Okay. D is 0.41. Okay, because it's not 0. Second one. A equal to 1000. D is equal to what? Star A is equal to D 0.0041 minus D. FD76. Here star A is 1000. 0041, and star A and D is what? It's 0.041. What? 41 minus 41, 0, right? It should be same, yes, it should be same, no? Okay, we have a problem here. Here we have a problem. Small problem. Because star A turns out it has another value. Every time D is different value. Why? Okay. 1000. 0. Go back. Yep. D minus. So it turns out that the order matters. Now, what? Yeah, now we fixed problem, but our problem is now different problem. Our problem is that this address is dynamic. Once we write to this address should be changed to 1001 or 1002, 1003. So we need to have this kind of increment. We cannot use this point counter. Instead, what we can do is that basically we can say, A equal to A plus 1. But point is that it doesn't help with this guy. I can say target. Can I say like this? It seems like no. 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 Number. Or I can make a small loop to iterate between 1000 and some kind of value, and it will check if it is 0 or not, 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 if it is 0 or not. Can I do like that? Yes, of course we can do like that. So it means here I will say equal to letters loop, and then oh, I already have it. It jumps to the hole before, right? So then star A, star A, now if I do star A is another thing. Jump to that address, jump to that address, jump to that address, jump. Oh my god, oh my god, oh my god. Guys, we haven't fixed the problem. We are spending 1 hour, more than 1 hour. Okay, star A. A is equal to the letter slope. Okay, yes. And then if the A is 0, then we can write. Right, we can write it. If it's not 0, we cannot write it. G and E not equal 0. And I think we should take this and put it before. Letter slope. Guys, maybe this is correct. Maybe. Let's go. Let's check it. Okay, tick. It is now. It is in another value. So we write successfully. Now when we go second time, we cannot go. This A star is not this A, it is this A. No. This is bad, guys, this is wrong. Can I use D? If I use D, then I lose the information. I cannot use D. So it means we need to implement in another way. We should think out of box. No, 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 it's incorrect. A equal to 6000, T is equal to A star. And we are checking T, we are checking the address. No, my brain is stuck. I don't know. My brain is stuck. Guys, do you have an idea? Any idea? Give suggestions. A equal to the target. Label calculate. A equal to 6000, T is equal to A equal to the loop, D not equal A. I wish I can use this one, but if I use this one, star A goes to not this address. I need to assign it to the D. Then I lose the information of D. You know, I can only to write D to the value which is appropriate. This is tough. This is tough. If you want to jump to the location, I mean, I don't have any other idea. I don't see. A equal to A plus 1, D is equal to star A equal to letters loop, T and G and E. qaysi yozsa bo'ladi? Which way we can write? Guys, I'm lost. We need idea. Let's read idea. Let's read some suggestions. You need to actually have a pointer somewhere in memory that you actually increment in there. It takes quite a few instructions and a few cycles, I guess. I see what we can do. Look. A equal to the target, right? And then what if we take address 5? What were 5999 and star A is equal to hexagon. Next time we should extract. Okay. A equal to A plus 1, D equal to Z1. No, guys. This is useless. This is not worthful. So we write to the address. Once we write it to the address, we say A 5999, and then star A is equal to G. I was thinking something like this, but now here A is equal to this value. So now we should say A go to the address A is equal to star A, and write A plus 1, and now this is forever. Let's check it. No, it doesn't work. Why? Because here we're taking A like this, right? No. Here we should assign A to 0, what? 0x? No? 0x 5999, and then A equal to star A, okay? Run. What? No, wrong. Guys, it's wrong. Fine. But now, okay, I got it. No. Write your value down. Yes. Turns out this G oh no. Now. Reset. Okay. Okay, now it makes sense. Change to this value. Go. Y. Okay. What is the value there? White 001. equal to star A. A is equal to the slope. No. Here we have a bug. A to this A address on that value. Star A equal to the D. No. Now go to the 5999. Get the address from 999 and write to the address value. Correct. This is correct, guys. Write to 1000, 1001, D equal 1001, and then A star 1001. I go to new order. Yes. 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 New value, right? D is not that value anymore. Oh my god, this is wrong. This is wrong. D is not that D. D is new D. It is It's not good really. I need this D. Look, star A is equal to the D. Okay, we will write to the D. I don't decide here. This is logic. This sucks. This logic sucks. It's not good. A equal to 5999. A equal to star A. Star A is equal to D. Yes, we write it successfully. But this condition is not good. Anyway. And now we get the D and minus star A. It will be 0 and then it goes back. So here, so here, this should not be that one and this should not be this one. We cannot just, we cannot just move the place order. Order matters here. Order matters here. So D minus A star A. Star A means address in A. Yeah. This was right. So then okay, this is proper. What about if I don't assign anything, guys? Just like this. Op. Op. And then I use D to assign here. And then maybe this work. Maybe this work. Reset. Click. Okay. No. Star A minus D is what? Unfortunately, we cannot use this one, guys, because this star A is from this address, not from this address. Okay. And then we go and read. Then we want to assign a D, right? Which is A star, right? Now we need to reassign. D is equal to star A. Star A from where? A is equal to 0x6000. And assign, and we'll get it and write it, and plus it means A equal to the A star, but before A equal to A minus 1, A C F. Seems working. Check solution. Simple problem is not fixed. Simple problem isn't fixed. Tick 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 tick. A equal to 1000. D is equal to star A. Let's see. You are wrong or I am wrong. In this address, my logic is saying that D is equal to this one. So that address value is 0041. And why it's saying 10 clock cycles? Does it mean like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Does it mean like that? This is important. Maybe we can reduce here, guys. Maybe we should think in another way. We can maybe reduce the complexity here. Because it's 26 clocks. Even if you change this clock speed here, it doesn't reflect on the evaluation clock. Evaluation clock is always 10 Hertz. D equal to star A. A equal to the loop. D A equal to this one. This one. This is extra. This is just to verify. What else? This is just to go back to the start. If I run, it runs, right? Can I use here just insert jump? Okay. GEQ. Do you want GEQ? This is 10 seconds. This is 10 cycles. Fine. We should check. We are so stupid, guys. I'm stupid, guys. I did this all, but overall, it is so long. Maybe we can. I'm definitely sure that we can reduce the complexity here. Is it valid? Of course valid. Yes. Okay, if you are... man. We cannot assign to use the value. Can I say to you target? Still no. That is a problem. See? Oh, hello. Q-man. Hello, welcome. I'm struggling to solve this problem for 1.5 hours, more than 1.5 hours. Target, A star, target. So we cannot do like that. It's illegal. Only by doing like this it works. It's taking 1, 2, 3, 4 o'clock. Can I do it later? Good question. Maybe yes. When then? When I can do it? I'm accessing to the address here. I'm addressing to the address here. A equals to the loop. D should not be equal to 0. Yep. A equal to the 5999 and A is equal to the star A, but nothing. Okay, or I can say it should be A or 1000. Make sense? Doesn't make sense. See, it doesn't make sense. D equal to D minus star A. Yes, that's right. It is registers, it is memory address in assembly, it is low level code, which I am becoming very stupid to solve it. My brain doesn't work. So here. So the idea was working fine, but we have a requirement that, see, just wait. We have a requirement. For 10 clock cycles, memory address at here should be x41, but for me it was taking 24 previously, but now it's taking 19. Now I have a bug. But overall we have the idea and we are solving basically on that idea, is that we are storing the intermediate to the subkind to the memory, to the fixed memory location. Like define temp x1 f. Okay, and then let's say like this, because defining it's not exactly expensive, right? It's not that expensive because it's not one clock cycle. This is one clock cycle. It's not clock cycle one. Yes. I am reading the D from the 6000 from here. Makes sense, okay. And then looping if D is not equal to 0, okay. A is equal to the 1001. Why? Here I want to check if D is repeated or not. If D is repeated or not. A is equal to the what? Temp. If you check the temp, in temp it might be the address value. And I used to say A equal to the star A, but here star A is like 0, 0, 0. It will be 0, 0, 0. It doesn't make sense. And then I said maybe let's say like this, but there is syntax error. Can I do like that? Or a number. Okay, I can make a bitwise only between the registers, not between register and a number. No, between registers. It means I'm not understanding this very well, because we can do, of course, bitwise or only with registers. Then if I assign D, then it is useless. D should not be 0, D should not be equal to the value. Maybe I can reduce this one. D equal to that A address, yes. T is equal to the GQ. Here maybe I can say, not D is JQD or D minus star A. It says problem. Why? One calculation per cycle. Why do I need this one? Multiple targets. Can I say A and then D? And then star A. Oh my god, no. So now, NAND game. No. NAND game. It says what? Syntax error. Oh, again. And now you guys, it seems I'm tired. No, I cannot assign like this. It's not like in Python. A and D, I can assign both of them equally. Okay. Can you convert from bit sequence into int? I am thinking from a project I am working on, but not internally complex like you are doing. Bit to integer. I think yeah. Bits to integer. So we need to have a mapping from the bits. In Python we have, you know, integer 12, right? Binary of integer 12. Binary of 2. 0, 10. Binary of 100. Okay. So it was like, you know, if you have 100 and then you need to divide by you want from the binary to the decimal, right? So if we want to convert from binary, then we need to, you know, like we need to iterate through each of them and multiply by 2. It was something like that. So then, for example, let's take a small number, bit 2, right? Bit is 1 and bit, so number 2 is 10 bits, right? So 10 means 0 multiplied by 2 plus 1 multiplied by 2, something like this. Okay, maybe this is correct, but let's validate for big number. Let's take it number 5. Okay, 1 multiply 2 plus 0 multiply 2 plus 1 multiply 2. No, it's not like that. Then. It is vice versa of converting decimal to the binary. Let's take the decimal 2, right? 2 divided by 2 is equal to 1. 2 divided by 2 is equal to 1, right? So 1 0 will stay. 1 divided by 2. 1 divided by 2, it is 0. So binary 1 is 1. No. Let's say it is 100. It seems I forgot it. It seems I forgot. It was like you